It's not rocket science. Society usually equates rocket science to one of the hardest jobs. We think rocket science is a metaphor for something that is almost impossible, extremely difficult, or unimaginable. And that is partially true. When we see these massive vehicles climbing higher and higher into the sky, we are amazed and impressed. As a maker and engineer, one of the coolest things is watching a rocket blast off into space. These complex machines combine all the types of engineering, and by literally controlling an explosion to propel themselves into space, they are marvels of what humans can do. And that is why when I got a spool of bronze PLA filament in a recent Profi box, I needed to print out a scale model of the Atlas V rocket. Besides 3D printing, another interest I have is aerospace and rockets, and I've always wanted some scale models of the industry's coolest rockets. With this perfect color for the iconic Atlas V, I decided to start a new series about printing, showing off, and talking about different rockets. Thought it would be a fun combo between 3D printing and awesome rocket technology. So let's first start off with some details on the mighty Atlas V, one of the most reliable and successful rockets ever built. The current version is the 5th iteration, with its debut flight in 2002. The expendable launch vehicle was originally created and designed by Lockheed Martin, but is now built and operated by the United Launch Alliance, or ULA for short. The vehicle consists of 2 stages, where the first is powered by an RD-180 engine using RP-1 kerosene and liquid oxygen. The Centaur second stage uses 1 or 2 RL-10 engines that use liquid hydrogen and liquid oxygen. There are 2 payload fairing diameters, a 4.2 meter and 5.4 meter option, which can have various lengths as well. In addition, up to 5 AJ-60 strap-on solid rocket boosters can be added for extra performance. There are 2 launch locations for the vehicle, one on the east and one on the west coast. It mostly operates from Space Launch Complex 41 at Cape Canaveral Air Force Station, but also launches from Space Complex 3E at Vandenberg Air Force Base. The Atlas V also uses a flight configuration key with its name, like 551. The first number corresponds to the payload fairing size, second is the number of solid rocket boosters, and the third is the number of second stage engines. The Atlas uses these configuration keys in its name for each launch because the vehicle is extremely configurable. The modular design allows for the ability to address many mission requirements, and this is why the Atlas may look very different each mission on the pad. The Atlas V is used for the most sensitive and critical missions. Because of its extremely high precision orbital insertions and 100% mission success rate, the Atlas is used for many secret government missions, interplanetary missions, and flagship NASA programs. The Mars 2020 rover Perseverance and the helicopter Ingenuity were recently launched on a 541 configuration Atlas. The vehicle is also becoming human-rated as it will fly the Boeing Starliner with astronauts on board to the International Space Station with a special vehicle configuration. The Atlas V is truly one of the most recognizable vehicles in the space launch industry. So now it's time to bring another Atlas V into the real world by 3D printing one. There are some great free models on Thingiverse, but I chose to go with the one by R. Tickner in the 551 configuration. That means a 5 meter payload fairing, 5 solid rocket boosters, and 1 RL-10 second stage engine. This model is fairly detailed and can be printed in multiple parts to allow for the correct colors to be used. Of course, I will be using the Filament 1 bronze PLA for the first stage parts. And I will also use Filament 1's Traffic White PLA and Hatchbox Black PLA for other parts. So I dropped the parts individually into Cura and sliced them up. I used 0.2mm layer height, 15% infill, and 2 outer shells. I went over to my Ender 3 and pushed in the SD card. I first inserted the black filament as I only needed it for the 2 small RD-180 engines. Next, I swapped over to the white filament to print the second stage, fairing, solid rocket boosters, and more parts. These parts took a while to print, and the SRB models were oriented in a weird configuration, so I had to use support, which turned out okay. So I moved on to the first stage with the awesome bronze color. This material is printed like butter and turned out amazing. The two parts took a long time to print, but I think it is totally worth it. After all the parts were finished printing, I got out the super glue and started attaching the parts together. The SRBs were pretty difficult to stick to the first stage booster because they were printed in a weird orientation and didn't come out perfectly. But I eventually got them on and connected the other parts of the rocket using a generous amount of super glue. The tolerances on this model are pretty tight, but with some sanding and twisting, they fit together nicely. Also, I left the rocket in two parts, so I can take the second stage off to show. I think it came out looking really awesome, but I'm missing a crucial part of the design, the fairing decals. So I hopped on my computer and printed out some of the logos, cut them out, and glued those on as well. I even added my logo as the customer just for fun. And with that, our 3D printed Atlas V rocket is complete. Now the Atlas V is finally complete and looks amazing at this 1/100th scale. Now that I see it in real life, I appreciate the incredible engineering of this vehicle even more. When the Atlas V is phased out and replaced by ULA's newest rocket, Vulcan Centaur, I can have a reminder of the amazing history and design. I hope you all liked this first video in my new 3D printed rocket series. Hopefully you learned something, were entertained, and gained a new appreciation for the mind-blowing engineering of these vehicles. If you did, be sure to leave a like and let me know in the comments what rocket you want to see me cover next. So, thanks for watching everyone. Like this video if you liked it, subscribe for more 3D printing videos like this, comment down below if you have any questions, and I will see you all in the next video.